Hello everyone, how are you guys doing? I hope you're all doing amazing. Welcome to another video, another fine day, another fine problem, and look at you looking all fine and ready to solve another DSA problem and get it under your hand. So without any further ado, get ready comrade, because today our problem is insert delete get random of 1. Now in this particular problem you're supposed to implement a randomized set class which will have a bunch of methods that are all supposed to run in O of 1 time complexity. Now if the name doesn't make it clear enough, you're supposed to implement three different methods, which is your insert, delete, and get random. And all of these methods are supposed to run in O of 1 time. So constant time, basically. So what is a insert method and what are we supposed to do there? So in the insert method, you're supposed to insert a value if it is not already present in the set. And if it was already present, you return true. If it was not already present, you return false. Now, the second method you have to implement is the delete, which is called remove here. They could have followed the same names, but that's fine for us. Removes an item val from the set if present, and if it was not already present, you have to return false. Now you have to also implement a get random value function where it returns a random value from the set that we have, and each of the numbers in the set should have an equal probability of coming up, and that's what you have to do. So how can we go about implementing this? So before doing anything, let's take this problem straight to whiteboard and try to understand what kind of data structures can we use inside of this class so that all of these operations are O of 1 for us. So let's go to the whiteboard and try to understand how can we make something like this O of 1 time complexity. Now, when we are first given a set, the first thing that we think about, especially in Golang, is using a hash map. So a hash map can be used as a set in Golang. So a hash map is great when I want to return a particular value in O of 1 time, but that is for the value inside of a hash map. For that, I need to know the key of the hash map. And when we are implementing a hash map as a set inside of Golang, our keys are the ones that are the unique values. So our keys work in a way to maintain our set. So a hash map will not be a great option if I want to return values in this particular case. So a hash map would be the thing we'll be using to store our keys, but it cannot be used to get any random value from our hash map. So when we think in a Pythonic fashion, when we implement a hash map, we have a bunch of keys and a bunch of values. Now in Python, we can use something like dot keys to get all the keys inside of a hash map, and then we can use something like random dot choice to iterate over these keys and get any random value. Now the issue there is again that when we convert our dictionary to keys, it will take off and time internally, because anyway you are converting that to a list, the hash map to a list. So that will take off and time. So it's still not of 1. Now, what is a particular data structure that can return any of its index in of 1 time? That would be an array, right? So in an array, if you have a bunch of elements, that any random element you want from there could be returned in of 1 time. So array is great for returning anything in of 1 time if you know the index of that particular thing. And in our case, the index is any random index inside of that array. But there is another issue if we just end up using arrays, because in array, it will be difficult for us to maintain the set property. So we have to maintain the set property, and at the same time, we have to ensure that we are able to return everything in O of 1 time. So we have to somehow use a combination of a hash map and an array so that we are able to index the values in O of 1 time and return them. And at the same time, in O of 1 time, we are able to check if the value already exists with us or not. So for that, we are using the hash map, which is equivalent of using a set in Golang. So I hope that made sense, and the way we'll be using it would be much more clear from code. I don't think I can explain it using the whiteboard much better in this particular case. So I'll try to code the solution up first, and then we'll try to come back to the whiteboard and see what exactly are we doing and how are we using a hash map and an array and using their properties of maintaining the uniqueness by hash map in O of 1 time, and maintaining and getting values in O of 1 time using indexing in array. So let's go back to our LeetCode and try to code up the solution. So first of all, we have to decide what all are we storing here. So first of all, let's try to write down that. So first of all, we have to store our set, which is going to be, in our case, it's going to be a hash map, which is a map, and our values are supposed to be ints. So I'm going to write int here. And for now, I'm going to say that I'm just using it as a pure set, so I don't need any value inside of it. So to create a particular set, the only thing that has 0 byte of storage inside of Golang is a struct, an empty struct. So that's why we create an empty struct with our map, so that it is like it is exactly equivalent of a set in any other programming language. So because this memory is gonna be 0 bytes. And other than that, we also need an array, as we discussed. So I'm just gonna call it nums, and it's gonna be a slice in this case, because we don't know how many such operations are supposed to come. Now the habit of calling a thing array comes from Python, and it's a really bad habit. Python are actually list. Array is something that has fixed size, and I just keep messing it up always. So it's a slice in terms of calling, not an array. So yeah, so in the constructor, we have to just return the randomized set, which is gonna be instantiated on the basis of our nums, and nums are gonna be instantiated like int, and set is going to be instantiated as map of int and struct. Now, what exactly do we want to do here? So once we have initialized our struct and our map, we need to somehow insert the values inside of it. Now, how can we handle insertion? Well, that's pretty straightforward. Whenever we are inserting a value, we can insert it to our hash map using simple like the syntax in Golang, where you just use our set, which is in this case going to be this dot set, and the val inside of this we are going to set to a empty struct again. So this way we are able to store the val as a key inside of our hash map, and it we have to also check that if the value already existed in the set or not. So to do that, we'll just do uh, underscore comma exists in this dot set val. So the exists will tell us if the value already exists or not. So if exists, we are gonna say it's gonna return true or false. I think if the value is already present, we are gonna return false. So yeah, so return true if the value was not present, and false otherwise. So here we are gonna return false, and before that we are also gonna insert this value, and at the same time, if exists was not true, we are gonna return true. So this is done, but we also have to ensure that we are inserting this particular value inside of our nums as well. So to do that, we are just gonna append. So our this dot nums is gonna be append this dot nums and our value. So this is this takes care of that, inserting into the nums, and the above line takes care of inserting into the set if the value doesn't already exist. I think we can also write it in that fashion. It's a bit written a bit differently right now. So if the value exists inside of our set, we're going to return false and not going to change anything. Else, we are going to insert it in our set, and at the same time, we're going to update our nums to insert the value inside of the nums array as well. Slice, again, slice. So yeah, that is there. Now, how do we take care of the remove function? So remove is again straightforward. We want to remove from a set. So to remove from a set, you can just delete the value from there. So you can just do delete this dot set val. And before doing that, again, you want to check if the value already existed or not. So you're going to check underscore comma exists, which is going to be this dot set val. And if exists, you need to delete it. So this works again, bad Python habit. You just need to delete this, and if it doesn't exist, you don't need to worry about anything. So else you're just gonna return true because it didn't exist anyway, right? If the value was, oh, it's the other way around in this case, so you're gonna return false here and you're gonna return true. Yeah, cool. And but you have to also delete from the element from the nums array, right? Because that's the array we are going to be indexing from anytime. And if you don't delete from the nums array, it might happen that it will show up when you are indexing from any other value. So how can we go about deleting from the nums array? Now, this brings us to the first issue that we face in this problem, that as we are only storing the map where we are storing the value directly, and inside of that we are not storing where the value is inside of our nums array. We don't know where exactly do we want to delete the value from. So if we want to delete that particular value inside of our nums array, we'll have to iterate the array, which will bring a cost of O of n, which we can't afford in this particular problem. So we need to somehow store the value in a way that we store that what all values have we seen till now, and inside of our nums, which is the array which we are maintaining, so that we can index the value in of one time when we want to get a random value from there, we have to somehow store in which particular index is a value stored, so that when we are deleting that value, we can uh, do that in of one time from our nums array or slice in this case. So how can we do that? So instead of initializing our set as a map of int to empty struct, we need to initialize it as a map from int to int. And in this case, we are going to again initialize it as a map of int to int. Yep, this is okay. Need another one, I think, for this. Yeah. And inside of our insert operation, we are not going to insert it with an empty struct. We are going to insert it with our len of this dot nums. So this will ensure that whenever we are inserting a value, we are also inserting which particular index does it take up inside of our nums array. And when we are deleting it, now it's pretty straightforward that we can use that val, and if it exists, we are just gonna use that val to delete that value. Now, how can we delete from the middle of an array inside of Golang? Now, one weird way of doing that, or offhand way of doing that, would be that we delete that particular value from the middle and then shift everything to the right of it back. Now, in the worst case scenario, this is again gonna take off and time. So the way we'll end up doing this is that we'll swap our latest index with this particular value, update that particular index inside of our hash map, and that way we'll update our this.nums to not insert our final value. So that way we are essentially removing that value inside of our nums array. So let's write the code for that. Again, I think that will help you understand the code better. So once we deleted this set from like deleted the value from this dot set, now we are gonna use that value that we obtained, which is the index in the nums array where it is stored, and we are going to use that to swap this value. So basically this dot nums v comma this dot nums len this dot nums. And again, the len operation in Golang is of 1, because Golang, whenever it creates a slice, it stores its length inside in the properties of that particular slice. So that way, we don't need to worry about having a maintaining the length ourselves as well, because Golang is doing that for us in of 1 time. So yeah, this should be replaced by this dot nums, and this should be len -1, which is gonna be replaced that is dot nums v. Cool. So this should swap those two values. And once we have the values swapped, we are going to update that particular index for the value that we just swapped inside of our set. So the value that we just swapped is going to be at this nums.v now. So inside of our set, which is this dot set, the this dot nums v is going to be equal to our index. So which is v again. Yeah. So this should fix that, and we have anyway deleted the value from our set, so we don't need to worry anything about that particular value, which is now at this like the length of the nums, which is at the final index. And now that this is done, we can update our this dot nums to be this dot nums and till len nums -1. So this will ensure that we don't include the last value anymore. And once this all is done, we can finally get to our last operation, which is getting a random value from the set. Now this is completely straightforward, because now we have maintained an array which we can index from in of one time, and we have also taken care of the set, which ensures that we don't return any value that doesn't already exist. And once that all is done, we can just return a random value from here, for which we are going to use a random library in Golang, which where we use rand.ints, and in there we want to use the len of nums. Cool. So this should take care of our this problem. I think we are missing a parenthesis here. And let's try running this once to ensure if the code is working or not. There can be a lot of compilation errors here. Okay, a syntax error on line 2. Wow, that was quick. Error. Unexpected this. Expected type. Okay, we don't need to write anything like this. We just need to use this. Again, bad habits from Python. I think this should be okay. Syntax error, comma and struct type, possibly missing semicolon or new line. Oh yeah, we just need again. Oh my god, I need to get rid of these Python habits. And syntax error, expected EA after top level declaration solution.go. I think this should again be taken care of from removing that comma. And on line 8, there is also an error, which is, why would that be the Oh, I think we just don't need to add the parentheses. Wait, just curly braces are fine. Let's see now. Okay, cool. Now this is working. And so we are now getting the error undefined del. So we need to do it like this dot set comma val. Cool, that is taken care of. And this dot nums is undefined for some reason, which should not be the case because we have clearly defined it right here. And this is our randomized set. And rand is also undefined. Int n, okay, not ints. So yeah, int n. So let's see what else is there. We were also getting that undefined nums. Oh yeah, undefined nums. That makes sense. It should be this dot num. Ah, silly me. What else? In which other line? 43. This dot nums, len, this dot nums. Cool. Now this should take care of everything. Let's try running this once again. Cool. And it is accepted. So let's try submitting this one. And before submitting, actually, let's go back to whiteboard to quickly understand what exactly we have done here, because I don't think I was able to explain it very well in the whiteboard before coding it up. So basically, we have a hash map where we are maintaining what all values we have received till now. And this takes care of checking the uniqueness for us, where we are able to see that if the value already exists or not, and we are able to return true and false in our operations as is expected behavior. Now we are using an array, which is also maintaining the same thing, which is the values inside of our hash map is also maintained in our array, because arrays are useful when we want to randomly output a particular index inside of our array to the function, which is basically our GetRandom function. So therefore, arrays are useful because they are able to return the value to us in O of one time, and the hash maps are useful because they are able to check if the value is unique or not in O of one time and return true and false accordingly. And by using the hash map, instead of using it purely as a set where we are just storing empty structs inside of it, as is a Golang standard for set, we are actually storing the index of the particular value inside of our nums, because that makes it easy for us to delete that particular value. So this way we are ensuring that how we exactly use our hash map so that it can be useful for us when we use the remove operation. And I've tried to build this code up from scratch, and also keep all the errors and things I faced during creation of this video, so that it is easier for you to actually understand how to solve a problem, and how in interviews you can actually use documentations for standard packages, because it can be the case where you are not exactly familiar with what exactly does a random.int is, but that is totally fine. You have to work on the logic and the understanding of what data structures you are using and how you are using them to save your space complexity or time complexity is what matters inside of an interview. So I hope the video made sense to you. Let's try submitting it now after all of these talking, and let's see if this works or not. Drum rolls. Oh wow, wrong answer. So it actually doesn't work in some case. Let's see what is this error. Um, okay, so it was expecting true and true, but it returned false. So finally, inside of an insert operation where the value is already present, I assume. No. Okay, so we initialize a random set. We did a remove of 0 from there. So that should return false because the 0 already doesn't exist. So false makes sense. Now again, we did a remove of 0. So again, that returned false. Now we did an insert of 0. Now there was no 0 inside of the set initially, so it returned true. Now we did a get random. Get random gave us 0 because that's the only value present inside of it right now. Then we did a remove of 0. So that should have ideally removed 0 from this particular array or num in that sense. And finally, it should return false. So why didn't it return false? When we did an insert operation. So inside of our insert, it should return true because this was not already present inside of our.
One eternity later.
Hey everyone, I'm back. I actually did find out what the bug was, and it's actually a really subtle thing. And it actually took me a long while to find this bug. I had to add print statements regarding the set and the nums at each step of my operation during the remove because the insert was working just fine. It was the remove that was a bit tricky, and this is where we were failing. So yeah, makes sense. We failed the tricky part. So the way we were doing operation here is that we first delete the set value. So we delete the key inside of our set that belongs to that particular value, and then we swap the value from the last element, which is our key value. So we swap these two values, and then we move nums by one so that the nums doesn't include that last index anymore. So, and at the same time, we also update the value for the nums v, which is our value that we shifted from the last index to this current index. Now, while doing this operation, we are actually missing out on a very specific edge case. And I guess maybe a lot of you might have already started filling out my comment section with this particular edge case and would have already found it, but I was not able to do the same. And the issue here is that if we remove the element, which is the last index, we actually replace it from itself, and we are able to shift nums by one so that the nums is fixed correctly because it doesn't include the last element anymore. And that's why when I was printing and adding all of those print statements, I was seeing that nums is getting updated just fine. But because of this operation, we add back the last value inside of our set. So in this particular case where we are adding a bunch of zeros and not adding anything else, our last element is actually 0. And when we remove this particular value, we remove it, replace it from itself, then add it back inside of our set, which is causing this issue. So in this particular case, the simplest way of fixing this could be if we just check that if v is not equal to our len nums minus 1, then only do we do this operation, because if v is the last index, then it must be removed, and that has already been taken care of. So this specific if statement, this small condition should be able to fix our bug, which was becoming a roadblock for us today. So let's try running this again with this particular fix. And oh wow, undefined nums. Yeah, it should be this dot nums. Let's try running this. Drum rolls. We don't need drum rolls here that we do in submit. Sorry, forgot that. So yeah, this case is finally getting approved because it doesn't add back up inside of our set anymore. Now, if we finally submit, it should work. So let's submit. Drum rolls, please. So it is accepted. It beats 94.97% in runtime and 96.41% in memory. Now, I don't trust these values too much, but what matters to us is that the solution is submitted, and it makes sense that it is a open solution to us. And we were able to build it like this because we ended up using two different data structures. One is our map and one is our nums array, basically, where we used both of their best properties, where an slice or an array is able to return any specific index to us in O of one time, which was useful in our get random operation. Then we use the property of set to able to identify unique values in O of one time, which was useful in our insert operation. And at the same time, we stored the indices inside of our nums in our set so that we can remove the values from our nums array in O of one operation. And That's how we finally build up the solution. I included the errors I faced in this problem so that it can help you in debugging problems and seeing that it is natural, completely natural to get stuck on problems and face weird roadblocks in edge cases that you hadn't thought about. And that is totally accepted. It is something that you improve with practice. And I faced this roadblock today while solving this problem, but we were able to debug it by adding a bunch of print lines. And I hope that will help you guys. And yeah, I know many of you may have already figured that out and might be shouting at me from your homes like, "What the hell are you doing? Why are you not taking care of the last index? What if it is removed?" I know I didn't do that, and it took me a while to understand that, and I finally did. So this solution is working. Hope you enjoyed the video. See you next time. Bye bye.